Hi guys, today we're going to look at the transition metals. So the transition metals are this middle block that's found, well, in the middle of the periodic table between group 2 and group 3 or 13. And then the subsection of this, the lanthanides and actinides, they actually fit in to the transition metal part, but they're taken out because they can't be fitted into the periodic table. So you don't need to worry about those really, you just need to worry about that middle block, the transition metals. Now, a reminder of metals, they're of a giant metallic lattice, and they have a sea of positive cations. Sorry, they have a sea of delocalized electrons attracted to the metal cations, the positive ions. Because remember, the metal loses an electron to have a full outer shell, and as a result forms an ion. So there's a strong electrostatic attraction between these delocalized electrons and these positive ions. That's the metallic bond. As a result, obviously, they're malleable and ductile because the layers of cations can slide over each other. So here are some typical properties of transition metals. Okay, we talked about malleability already. So they're strong and hard, otherwise. They're good conductors of heat and electricity due to the localized electrons being able to move and carry the charge. They have high densities and will sink in water, unlike group 1. And they have high melting points, except mercury, which is the only liquid one at room temperature. So sometimes you get asked to compare group 1 and the transition metals. So remember, transition metals, unlike group 1, which can be cut with a knife, these cannot, obviously. These are just, think of a typical metal. Think of copper. They're harder, stronger, denser, and they have high melting points. They're also much less reactive than group 1. So group 1, when you drop it in water, it kind of moves around, fizzes, dissolves. This one doesn't. Okay, and it doesn't even react with oxygen or water very readily. You have to heat it. So if you ask to compare something, you must use comparative statements. So for example, it is less reactive. Don't say they have a low reactivity. Use comparative language. And there really isn't much else you have to know about them. The only thing maybe I would add is just a few more typical properties. So I'll attach this PowerPoint as well. Some of the other properties that you're looking at would be here. In fact, because this is the main useful slide, I'm just going to screenshot this for you guys. I'll save this. So we'll save this now. There you go. So they're often used as catalysts. That's something else to note. So for example, iron, Fe, is used in the Haber process. And they form colored compounds. And they have variable charges as ions. So unlike group 1, which has to be +1, group 2 has to be +2. Iron, for example, Fe, can be +2 or +3. So they have variable charges. Okay, that completes the transition metals. Now I'm going to show you the group 8 or the noble gases, sometimes group 0. So here are the first 3 in order. What you'll notice is they all have a full outer shell, because if you have 1 shell, it can hold a maximum of 2. And for 2 or 3 shells, it has a maximum of 8. So they all finish on a full outer shell. That means they have no tendency to want to gain or lose electrons. So noble gases are inert and unreactive. They do not need to gain or lose electrons because they have a full outer shell. Do not say they have the same number of electrons in the outer shell. They don't. Okay, this one has 2, these have 8. What happens to boiling points down the group? Well, it's the same as group 7. As they get bigger, the atoms get bigger and they have more electrons. So they have stronger attractions between the atoms, which we call stronger intermolecular force of attraction. So more energy you need to separate the atoms. Now, technically, if you're an atom, you're a singular, you're not actually a molecule. So I would just say strong force of attraction. The attraction between the atoms gets stronger. If you kind of do A-level, you'll learn exactly what this invisible force of attraction is, but it's not a covalent, it's not an ionic bond. It's just called a force of attraction. And the bigger you are, if you remember the bonding topic, the stronger your intermolecular forces. For the purpose of exams, you can get away by saying stronger intermolecular forces, so stronger IMF. Remember, they're monatomic, which means they exist as just He, Ne, unlike oxygen, which is O2, or nitrogen, which is N2. So that's the only real thing you need to know about them, okay? So with that, we've now done the transition metal and the noble gases and all the history of the periodic table and group 1 and group 7, and it's all done. Okay, so the topic is complete. Thank you, and see you next time.